All right. Well, welcome, Gabrielle. Um, Welcome, everybody, to this meetup. I'd like to introduce Gabrielle Stichweh. She's a prototyping technician at the 1819 Makerspace, which is in UC's 1819 Innovation Hub just off campus. And today she'll be presenting on the primary considerations of equipment when setting up a 3D printing ecosystem. And in particular, this includes hardware, software, and print queue management. So with that, please proceed, Gabrielle. Welcome.
Hi, everybody. It's so nice to be here today. I work here at the university. And if you don't mind, I'm just going to go ahead and share my screen and get right into this presentation. I've got several slides to go over. And then at the end, we can either review any comments or questions that have been left in the chat, or you can just shout them out. So let's see if I can share my screen. All right, have we all got this?
Yep.
Great.
Looks great.
So I'm not totally sure what everybody in the audience's understanding or experiences with 3D printing, so I'm going to keep it both general and get a little bit into the weeds today, but just a little bit of background on me. I went to UC, got my degree in industrial design in 2020, and I worked here at the Makerspace as a co-op and as a part-time student worker for a couple of years. And then in January of 2021, I became the full-time prototyping technician. So our shop is broken up into two parts. We've got the prototyping lab, which is laser cutting, 3D printing, graphics, all of the things that aren't supposed to be able to hurt you. Of course, we know that occasionally, if someone's not trained, you can make a little mistake, but it is the safer side of the shop. And then we also have the fabrication lab, wood shop, metal shop, welding, CNC, things like that. This is a photo of one of our earliest teams right after COVID. So we have grown to have about 30 members in our team. That's 5 full-time staff members who work for the university, and then a huge array of co-ops and part-time student workers and things like that. A little bit more about me. I also do a textile studio practice. So I have a studio space in Camp Washington, and just this semester I started pursuing my master's degree here at UC. So keeping very busy. 1819 is the newest makerspace on campus, and it is a unique connection point because it serves the entirety of the student population. So it's not just college-based. And it also has offices for local industry. So Fifth Third, P&G, Kroger, all those guys have offices here. So they have access to our makerspace and to the amazing student talent that comes through here. And we can kind of connect them both with students and with the startup infrastructure here at UC. So while most of our membership here at the Makerspace are undergraduate or graduate students or researchers with the university, we also do have professional industry connections that come down here and use the space, and we have several in-house startups that use the space as well. So it kind of runs the gamut of the level of understanding that people have as they're coming in, as well as the uses that they're finding for us. So we really do everything from first version, iterative prototyping, all the way up to a final golden prototype for someone's project or someone's business. We offer both DIY services and a service center model. So because of COVID and ever since, all of our printers are on service center. So people just submit files to us, we get their STLs, we get all of their project details, and then our student worker staff slices the prints, manages the print queue, and then once those parts are done, we deliver them. We allow people to come pick up the parts. I really like that system. I'm sure that's pretty similar to what some of you are used to as well, just getting files from people and then kind of trying to either communicate with people or figure out based on the files different qualities, what sort of orientation you want, what sort of material would be ideal if we need to contact someone and figure out, okay, maybe you think you want desktop FDM, but actually this part would be better for SLA. So we always try to be in communication with people to try and figure out what they want. These are just a rundown of some of the different tools that we have here, which I listed off earlier. We try to make sure that we get everybody exposure to multiple different types of making. So if we can bring someone all the way from a 2D sketch through a 3D print, a laser cut model and a CNC version of that project, that's really exciting. And it gets everyone a little bit more experience with the types of technologies that we have here. Um, all of these listed technologies we have some sort of training for. So in addition to running a 3D print queue, we also have certifications, workshops, and introductions to all of these technologies. Kind of just depends on how in-depth we want to get with those particular tools. All right, let's get specifically into the 3D printing infrastructure here. I'm going to talk primarily about both FDM, fused deposition modeling, and SLA, stereolithography modeling. If you don't know, it uses two very, very different types of technology. So FDM is using filament, it's using a long spool of material. That type of material depends on which specific machine we're talking about. And then SLA, that uses photosensitive resin. And there are a couple different types of methods that you can cure that resin to make 3D prints. And we'll talk about those in a minute. When I'm comparing these methods and I'm introducing someone who's new to the shop to, what type of printing do I need to do to get the model I want, I always try to start them off on desktop FDM because it's quick, it's iterative, and I really like to enforce that you should not expect a final perfect version on your first try, right? CAD is kind of a magic black box, if you will. There are plenty of people who come in here and don't have that baseline understanding of, this geometry just does not work in reality. You can't have absolutely any type of 3D model exist just because of the manufacturing techniques that are available to make those things in different materials. And I would say a lot of people feel really hesitant to come in here, understand that it's going to be multiple rounds because of the project timelines that we're working on. But FDM, easy material storage, slightly less expensive materials, depending on which machine we're talking about, of course. And you can get your models a lot quicker. And then we also have SLA printers. We use Form 3s here in the shop. So higher tolerance parts, isotropic parts. You have different types of material options. So having an optically clear object is really hard in FDM because of those layer lines you're going to end up with, whereas our SLA printers are going to give you a slightly clearer solid object to work with if that's something that you require. And we have a lot of medical researchers here who are actually using SLA as their final versions for their research projects. So they come in, they do a lot of iterations, and then they end up leaving with some sort of machine, parts of which are made on our SLA printers. When we're deciding, okay, what type of machine do I want to buy? What is right for my shop? Always starting with, do I want FDM or do I want SLA? What kind of level of material qualities, level of resolution, what kind of tolerances are we talking about? So that's the first decision that I always recommend people make. And then within each of those machines, there are different types of models that you can get. So either direct or Bowden drive. That's going to depend on, how much vibration are we concerned about in our final models? What types of materials are we going to be using? And also, what's our budget? We use only Bowden tube model printers here. I find that those tend to be a little bit more on the expensive side, and we'll get into the specific models of machines that we're talking about a little bit later. In addition, I've just got a list of a couple different considerations that we're making. I do prefer to use the Ultimaker printers with the Ultimaker materials, and that restricts me to the 2.85 millimeter filaments. If you ever tried to buy filament for your printer, you have probably at some point bought a filament that simply will not run on the printer you have. It's an easy mistake to make, both because of the size and the material qualities that you're working with. Maybe you're buying a material that requires a higher temperature than your printer is capable of producing. Now you can't use that anymore. So I always like to look at the purchases I'm making as an ecosystem holistically, rather than just assuming whatever, magic material came out this week and is really big on YouTube and TikTok that people are asking after. Well, maybe that's not ideal for the specific machine that I have to run. Kits versus prefabs, that's another topic that I would like to touch on really briefly, there is maybe an assumption that if I get a 3D printer and it arrives as a kit that I have to put together myself, that's not going to be as high end or as high quality a machine as something that I just purchase and then it arrives at my doorstep completely put together, ready to plug in and just press go on. I don't think that's necessarily the case. I've seen a lot of people who prefer to purchase kits, build them, and then mod them themselves, and they get really beautiful results on those machines. So if you have the comfort and the confidence to purchase a kit online, put it together, and then maybe make some custom adjustments, absolutely feel like you can do that. And that's not going to necessarily mean that you have lower quality prints coming off of that machine. Open versus closed systems, depending on what brand you buy, they're going to kind of restrict what modifications you can make on the machine, what types of materials you can make on the machine. For example, we use Stratasys printers here. You have to use Stratasys consumables. You have to use Stratasys materials. It's a very, very closed system, and it does restrict what you're able to do on those machines. So do your research before you jump in to one ecosystem and really marry yourself to that, because you may find that, I don't know, the consumables or materials that they're offering you just don't fit your needs. So have a good understanding of how the IP is going to work in there, how dedicated they are to restricting you to one specific ecosystem. As far as software goes, that is going to depend again on what machine you buy originally. So I always like to imagine that the 3D printing system, it starts at 3D modeling something. You can't 3D print something unless you have that STL file, unless you already have a body to print. And so I teach Fusion 360 here. It depends on if you're a private or a public institution, if you're a school or if you're not, what modeling software is going to make sense for you specifically. Fusion 360 works really well for us because it's free for students, which is great. And it includes a lot more functionality than other individual systems offer us. So Fusion is a modeler, you can render, you can animate, and you can do your CAM all in one program, which is amazing for our uses here, because we are trying to get people on multiple different machines for, say, one project. If you've got more of a professional environment, I'm sure a lot of you are familiar with SolidWorks. It's a lot more expensive, but it does give you that specialty use that you might be looking for. Slicers are the programs that you're going to use to prepare your 3D modeled file to actually run on the printer. Printers are pretty dumb. They're going to do whatever the code that you send them asks them to do. They can't read the 3D files. They can only read, the G code, the very simple commands that are telling them move this much in the X, this much in the Y, extrude, don't extrude. So having a slicer that you're really comfortable with is very important to get you to that point. We use Cura here, which is an Ultimaker product. So it works really well with the Ultimaker machines that we have, but it is a pretty open platform. You can slice files for other types of printers. And I do recommend that people use that slicer. Personally, a lot of our students who are both printing here at the Makerspace with our machines and also have their own 3D printers at home, they really like Cura because it can go across platforms and it has a ton of options to customize your slicing settings. They also are updating it all the time, rolling out new beta functions that you can test out. So it's a really great platform. I like it a lot. I also know people who use Simplify 3D or the Prusa slicer if that's the machine they're using. So very personal decision as far as which slicer you're going to use. It's also important to understand that you might choose to use one ecosystem for slicing, maintenance, and queue management, or you might choose to have multiple different systems. At the moment, we are using Cura as our slicer, and we are using Airtable as our maintenance and queue management system. I really like to have Airtable as a resource to do those things because it is if you haven't heard of it, it's a very low code, almost Excel on steroids. It's table based, so you can put all of your data in there, but you have a lot more types of information that you can store in Airtable than you can in Excel. It's not just based on columns and rows. You can kind of assign certain values to those different fields of information. So we use Airtable for our forms. If a member of the makerspace wants to submit a print queue, they go to the form on our website, which is run through Airtable. They fill out that form, give us their STL, give us all their information, anything else we might need. That form then comes into our Airtable backend where our team can look at all that data. We've got one column for all of the information that the member has submitted to us. We have another column for all of the information that we need to generate. So place the sliced file in there, record the amount of machine time it's going to take, record the amount of volume, anything else that we need to know. And then we have one final column for communications. So the really cool thing about Airtable is that you can have it automatically send out emails. So it sends out an email when someone's job has been received. We can automatically have it send out an email if we have any questions, or if someone specifically requested to receive a cost estimate before any work starts. Just a simple click of the button in that program, it sends that all that data out to them. And then also when our job is finished and it's ready to go out, all we have to do is move it to a new column in Airtable. It automatically sends out that email that has the cost, time, and pickup information that our members need to know. So it's very useful for the entire lifetime of a print. It's how we do all of our queue management. It's also how we do our maintenance recording. So that is both anything that we need to be prompted to do for repetitive maintenance. So, when we buy a machine, we input all of the data that it tells us every month, do this, every year, do that. And Airtable records all that information. It's also where we put all of our responsive maintenance. So if a machine breaks, we have to buy a part, we have to fix something, we have to do a hot or a cold pull. We put that data in Airtable, and it's super easy to organize both by, okay, when have I done maintenance? What type of maintenance have I done? And it's easy to see which machines are habitually having problems. So using Airtable as our maintenance database has let us know, okay, maybe we expected the lifetime for these machines to outlast these ones, but because of the way they're being used, because of this data I have on the repetitive maintenance tasks that are happening, I know I actually have to replace my SLA machines before I replace my FDM machines because they're just having more problems. Airtable is a great tool, and it does have a free function, so you can have a certain number of bases and a certain amount of information in there without paying anything. We in the shop use the paid function for the staff members, and then we have a shared sign-in for all of our student workers. So it's really easy to see who in staff edited something. Everything's tagged with your name. You can record who's made changes, what, and when. And then all of our student workers share that one sign-in. So it's a little bit more difficult on that end to see, all right, who made this change, who did this maintenance, unless they specifically sign. But it is a great way for us to save money. We don't want to have 20 paid memberships for our student workers. So you can kind of push and pull with how much you're trying to spend on this service, and how customized you want it to be. We have spent a fair amount of time building these systems. So for example, just became July. It's a new financial year for us, so we had to build a whole new table for our new financial year's submission system. That took me like 3 days of dedicated work to build that out and make that happen so that we can use it for the rest of the year. And the amount of maintenance that I'm doing on that Airtable system to keep it running and to keep it functional, like less than an hour a month, really, really limited. So there is that initial time investment in getting the system to do what you want, but after that, it runs like a dream. And I have zero coding experience and have still been able to build this out to do everything that we need. So I really recommend that both for queue management and for maintenance if you need a system for that. In terms of literal queue management, moving from your computer to the machine, there are a couple different versions you can go with, either printing over Wi-Fi or using flash drives. I'm actually surprised at the number of large-scale print farms, if you will, how many of those do just use flash drives because they feel the value of physically pairing the printed object with the file that it came in with. And for them, using a flash drive, plugging into each machine as it's starting works. For other people, you're going to want an online system where you can send from your computer to the machine without having to get up or going to find the specific machine you want. I was really surprised when we got our newest system of FDM printers, how difficult it was to set that up. Um, what we have, and we'll talk about this later, is the Ultimaker 2 Plus Connect machines. So it's an older version of the Ultimaker machine, but it now is supposed to be able to print over Wi-Fi instead of requiring you to use a flash drive. Everything I read about that said, oh, it's great. You can use Wi-Fi now. You can use their new digital factory system to manage everything. And then when I got them in this room and when I got them plugged in, the specific gateways on our network, because we are on the UC network, there are a ton of restrictions. It's a very closed network, do not allow those machines to print over Wi-Fi. So a huge advantage I was expecting when buying these 10 machines just isn't working for us right now. So I had to come up with kind of a fallback option, figure out how to move back to using flash drives, move back to that kind of get up, walk over and start a print mode of working. So just understanding that there are things that you might not expect, even if other people are able to use the system the way that it's sold, depending on what your company or where your workplace's policies are in terms of the network, it's going to restrict what you can do. There's also a value of having a system where you have editability for a file. So if you send a file over to a machine and that file fails, are you still going to have access to that slicing information? Are you going to be able to look at those print settings and see, okay, why did this print fail? Can I go back to that file and change those settings so it doesn't fail again? Or did I just receive an already sliced G-code file from somebody, plug that straight into the machine, and now I have no backwards editability on that information? I always like to make sure that we do keep every step of file changes so that we can go back and fix any mistakes that were made. And there are third-party programs like 3D Printer OS, which is a pretty expensive queue maintenance program that I think a lot of larger companies are using. It can run a ton of different machines on a ton of different platforms, and it does some really nice queue organization for you. But unless you have that capital to invest in a system like that, building your own can be really helpful, which is what we've had to do here. So like I was talking about earlier, we use Airtable for maintenance, project, tool library, price list, and the print queue. The tool library is really nice just because here we want to have something published. We want our members to be able to look at specifically what model of machines do we have, not only for 3D printing, but for our wood shop and our metal shop and all of that. And the one really unique thing about Airtable is that it has multiple modes to publish in. So we have a completely closed backend. Nobody can edit data from outside. And we also have that front end that we can publish. People can just view, not have edit abilities on our data. So they can look at our list of machines and they can look at a live timeline of our print queue and helpful things like that. Let's talk a little bit specifically about FDM machines. So the main priority that I've had today is keeping it under 3K. So FDM machines that are reliable, that I see people using both on campus and in professional environments that are going to cost less than $3,000. And I found that a lot of hobby level machines, it's what they're sold as. They're used in industry, they're used on print farms to a surprising amount. Because I think most of those hobby machines are more modular, you can customize them a lot more than some higher end closed versions of those machines. So the first one that I'll honestly recommend is the Ender 3. I have one. I know a lot of students who have them, a couple students who have their own unofficial print queue systems that they can, charge their friends for rather than coming to a resource on campus like us. And they can have that print running 24 hours a day. It's reliable, it chugs right along, it's really easy to maintain. And almost everybody I know who's purchased the Ender 3 or another Ender product has really liked it and recommended it. It is very inexpensive. It's the least expensive one on our list today, coming in at around 200 bucks. If you go to Micro Center, you can get it for even cheaper than that if it's on sale. And it's a great little machine. I really like these. The next one is the Prusa, and this is the least expensive machine that is in the university system. So there are a couple different labs on campus that use these. They're a little bit more expensive, and you can also decide how much you want to pay depending on if you purchase it as a kit or as a pre-constructed machine. So you do have a little bit of a space to decide in there. It's a really popular printer, and a lot of them are used because they are a low or an in-between.
Gabrielle, we seem to be having some issues with the volume at the moment. You're cutting out. Can't really hear you. Patrick, were you noticing that as well, or was it just me?
No, sounds like her audio just cut.
Yeah,
Very
that's what I
strange.
got too.
How
Same
about
thing.
now?
Yep, there you
There
go.
we go.
Fantastic.
Back?
Yep.
Okay, great. All right, let's try this then. All right, I'm going to move on to the next one I've got to talk about today, which is the Bamboo Lab. This is new. I don't know if any of you have really looked into these machines. They were on a Kickstarter and now they're available for purchase. It's a little bit more expensive. It's about 1,200 bucks. And because it is such a new technology and such a new company, I am hesitant to buy one myself because, who knows exactly what types of problems are going to have with this machine until they're really tested by all sorts of different people making all sorts of different projects. But I do know a couple people who've purchased them and are super happy. They do a variety of different materials. So you can do, I believe, TPU. You can also do multiple materials in one print on these machines. And because they are so new, they're always updating. They're pushing new settings for these. And people, it seems, are really happy with them so far. The next one is the Dremel. And I will absolutely say that there are a lot of K through 12 schools where I've spoken to the teachers, they have a Dremel, and not a single one of these people has recommended that I buy one. They're having all sorts of issues with them. They're apparently really finicky, and it's also an extremely closed system. It's hard to get any fixes, any maintenance in there that's not the officially recommended way to do things by this company. And it sounds like they do break down a lot and they are pretty tough to use and pretty tough to maintain. So although it is on the cheaper end, I wouldn't recommend purchasing one of these. I believe that they just recently changed which version of the printer they have available. So some of the older versions they don't even sell anymore. They're looking to produce new ones. Not a company that I've ever really enjoyed working with. The Ultimaker 2 Plus Connects, these are the ones that we have in our shop. And we actually just recently switched from using Ultimaker 3s, so the newer version of this machine. Once those were all done, they were at end of life. We purchased 10 Ultimaker 2s. And there are a couple reasons that I chose to do that. They do have several newer versions. They have the 5s and the S series. They've got 7s out now, and those have an advantage of material storage being integrated. You can buy these really silly high stacks where you've got your material storage on the bottom, the printer, and then on the top they have the filter like you can see on this one right here. But I've found in our shop specifically, we are only running PLA on our desktop FDM printers. A couple reasons for that is it's not a totally enclosed system, so the material is sitting exposed on the back of the machines. And because our lab is in a basement, the temperature, the humidity, the environment's changing constantly. And by the time a roll of dissolvable support or some more sensitive material gets to the hot end of the machine, it's just not printable. which has been kind of disappointing because the first versions of this machine we bought were dual extruders. They could do a material and a support material or two colors of material at the same time, and it just wasn't working for us. So the tech that worked here before me made the decision to restrict that to only PLA. It's the only thing we print on these machines, and we've had much more reliable experiences with the desktop FDM printers since then. So we went back to the twos. They are workhorses. Everyone who's worked with these twos that I know really appreciates them, says they last for years. And because the fives and the S series, they're a little bit newer, there's less known about them. And the few people I know who have purchased them have noted that they aren't quite as reliable. They aren't running as long and as consistently as the older versions of machines that Ultimakers put out. So we did decide to purchase the twos, as well as because on that top, you see that UFP, the ultrafine particle filter. It's important to think about safety when you're using microplastics every day. There is some research done about how these particles of plastics are affecting people who work with them day in and day out. But as someone who works with students and who is around these machines, 40 hours a week for multiple years in a row, I wanted to make sure that we could integrate as much of a safety precaution, as much filtering as we possibly can. So we did end up springing for both the machines and the filters that go with the machines in here. A couple different materials that we run here in the shop. We do PLA, like I said, only on our desktop FDM machines. And then for our industrial FDMs, which we use Stratasys machines, we have a Stratasys 370 and a Fortis 450 MC. Those are entirely enclosed, so the spool of material is never just in the open air. We can use some different materials like ABS, TPU, nylon. We also do a carbon fiber nylon, and there are plenty of other materials that you can use with those systems as well. I find that mostly people are using either the desktop PLA or they're jumping all the way up to nylon because they need it for their specific project. A lot of our aerospace engineers are using those. Higher, stronger materials for their projects, as well as anyone who needs, something flexible. You got to use TPU or you have to use a flexible resin at that point just in order to get those material qualities that your project requires. As far as SLA goes, there are, I would say, a lot more printers on the less expensive side that I would recommend for these machines. And I'm going to kind of lump everything together. I know that we've got a couple different methods of resin curing prints, SLA, which uses the small laser and a series of mirrors, as well as other versions like DOP and LCD that use a screen to cure an entire layer at once. Not super important that we go into how those are different, but the one main difference I want to highlight is that SLA, using just a mirror and a laser, is a lot slower than the ones that are using a screen, because SLA is curing a little tiny speck of light at a time, and then the ones that use a light screen are curing an entire layer at a time. So depending on the resolution of that screen, you can still get really, really high quality, high resolution prints. But we do use SLA in here because we're happy with the machines that we've purchased in that mode. First one that I'll talk about is the Creality. I'm sure a lot of you have heard about this. It's a pretty relatively open system, very, very inexpensive printer. And it uses a screen, has pretty respectable resolution settings, but everyone who I know who's worked with these has had trouble with some of the software aspects. The backends are a little bit laggy. They can have trouble slicing and exporting their prints over to these machines. So I've had a couple people bring up concerns with the way that this entire ecosystem works together. The Anycubic Photon is awesome, a little bit more expensive. It's closer to about $800, but they do have an option for automatic resin refilling. So if you're printing something overnight, that can be a huge advantage to you. Higher resolution screen, since they're working with the 6K. And I know people who have had these for a while and they're really happy with how easy they are to maintain, the quality of the prints that they're getting off of there, etc. Frozen Sonic Mighty 8K, so we're going up in resolution here. We've got 8K screen, kind of slightly more expensive than the last one. It's also just physically larger. When you're looking at an SLA print, a lot of people are going towards that method because you don't see those layer lines that you see in FDM. You get higher quality, higher tolerances than you maybe can using an FDM machine. But because of the way that this system is working, you've got to have your tank of resin that often restricts the size that you're working with. So occasionally I'll recommend that people break up their parts, split them, key them, print your big object in multiple smaller versions, and then glue it together at the end of the day. But this is one of the larger sizes of SLA machine that I've seen people working with. So if you care about printing really, really large objects, this might be a better way to go. The ones that we use in the shop are the Form 3 Pluses. Before we had Form 3s, we had Form 2s. I've been really happy with the Formlabs systems. They do the printer, all of the post-processing equipment that you're going to need, and their queuing system is amazing. They have their own slicer, they have their own queue ecosystem where you can get a lot of data on the success and failure and use of material for your prints, if that's something that matters to you. Their backend shows you a long, long history of the specific jobs that you've sent to, which specific printers you have access to, what materials those printers are running, how often you're succeeding or failing in those prints, how specific the time commitment has been for those prints. And you can gather and harvest a lot of data from that software to analyze the cost effectiveness of your printing system. It's really important to us here because we work with federal grants. We have to know that information. And if you are, cutting it really close on margins, or if you're really caring exactly how much time and money is going into each and every print that you're sending out, this is a great way to get that info. We do a couple of different materials here at the Makerspace. Most of it is just the simple color SLA materials. You can also do draft, which goes way faster. I've been really impressed with the draft material on these printers, as well as different engineering resins, which are just the resins with different material qualities. You can get flexible, high temperature, elastic, tough. They're also coming out with different materials that you can use in like jewelry making, dentistry. They do have an entire line of biocompatible materials. Now, what that means kind of depends on not only your printer, but also your post-processing setup. Because if you're mixing your biocompatible materials in the same washing material as you're using for your non-biocompatible materials, you have to be aware on how that cross-contamination is affecting your ecosystem. We personally do not print anything that is intended to go into prolonged contact with skin or inside of a body. That's not something that we're comfortable claiming would be safe coming out of this shop, just because we do have so many different people working on the post-processing, so many different resins going into that material. But if you have a specific need for biocompatible prints, it is something that you could set up in your own shop to make sure that you are not cross-contaminating and you are keeping all of those resin prints safe. I've said the word post-processing a couple times. If you haven't used SLA machines, you might not know exactly what that means. But when your part comes off of the printer, you're going to have to wash it off in some sort of alcohol solution just to get all that extra resin off the surface of your finished print. Once that's done, you're going to want to cure it in some sort of UV chamber. I really like that Formlabs has all three of those steps on offer. You can purchase the Formlabs printer, wash station, and cure station. They work really well together. And then any other printer that I've mentioned today, they also have options for how you can buy those complementary parts of the ecosystem as well. Really briefly going into some of the other types of machines that we do have on UC's campus. These all go way above and beyond the $3,000 limit mark that we're focusing on today. But they're also opening up different modes of printing. So we're only talking about FDM and SLA. You've also got selective laser sintering. You've got things like PolyJet, which can do full color prints. Now there are more and more FDM printers that are claiming, full color print capabilities, and that's really exciting to see because some of them are looking really great. the bamboo, for example, can do multiple colors or multiple materials at once, but things like the Objet and some of the higher end Stratasys machines, I know we have a J55, which is a PolyJet printer over on Med Campus, which just produces the most amazing multiple material prints that you've ever seen. It's really impressive, but you are, of course, paying for that increased quality and increased options. So if anybody does have questions about some of these other machines, I've personally worked with the Stratasys F370 and the Stratasys Fortis. Feel free to message me after this if you have any questions about those particular pieces of equipment. These are my recommended machines, the Ultimaker 2 Plus Connect and the Form 3 Plus. We've had to revamp our desktop FDM and our SLA sections in the past couple of years. So we have shopped around, we've looked at the market, seen what's available, and these made the most sense for us. I like that both of them have a cohesive ecosystem. Not only the printer, but also the slicer and the queue management systems are integrated into what you're buying. And they're super easy to maintain. There's always somewhere that you can buy any replacement parts that you need, or in the case of the Form 3, I don't think I've ever paid for a replacement part. I think most of the time they just understand that maybe there's an issue and they send it to you for free, which is amazing, as well as the documentation that's going into those parts that you're receiving. So whenever I'm getting a replacement part, I'm getting a really amazing PDF guiding me through all the steps that I need to know to go in, safely take apart that machine, replace the piece that it needs, and put it all back together. And I just really appreciate that, mostly because we've got so many student workers in here. So that's a task that you can set them on and not worry too much about, not having a machine together at the end of the day. That is what I have here. I have not been checking the chat, so I'm not sure if there are any questions yet, but let me stop sharing my screen and we can get to that.
Yeah, the only point somebody brought up was just that the bamboos being made by a Chinese company might be a concern as far as security issues for some companies. That was the only thing that came up in chat.
I did actually have a question. So you brought up the service with the Form 3s and the Ultimakers. We've actually got 2 Form 3s here at Crown that we use all the time in the model shop. And we did not opt for the service contract on those printers. Do you guys opt in for all the service contracts that come with everything?
We usually don't. So I think for all 3 levels of printers, we have the Ultimakers, the Form 3s, and the Stratasys. We don't have contracts for maintenance on any of those. If something comes up, I'm ultimately responsible for it. And if I need to call their support techs, they have different levels of how long they'll spend with you on the phone and if you get to discuss anything with them same day. Because we do have 10 desktop FDM machines, 6 SLA machines, and 2 of the industrial FDM machines, having one down for a week isn't the end of the world. So we've been okay not having those contracts and just saying, if my contract means that I'm not going to get same day assistance, that's okay. I can make it work.
Yeah, I was just kind of curious because we've had unparalleled reliability with the ones that we've had, but at least with the wash stations, typically if there's a problem, once you're out of that warranty phase, it's either buy a new machine or buy a new machine. They typically don't service anything, unfortunately. Like we had a board go out on a wash station and they would not sell us a new board. It was, oh no, you need to give us $800 for a new wash station. Which I can understand that to a degree, but like they're so good about the other aspects of their service with the Formlabs products. Just sometimes their service is a little spotty, I guess, but they will drop ship you a brand new printer if you need to replace it, like literally next day. I mean, it's crazy. So if anyone's
It
interested in
is.
those, they're pretty good about that part of it.
Yeah, I've been really impressed with how quickly they will ship you a replacement printer if you need it. When we got our Form 3s last year, there was some sort of manufacturing issue and none of them would do the automatic resin filling. There was a small piece in there that was the wrong shape. So as soon as I even mentioned, I'm having one printer, the first one I plugged in, it wasn't filling with resin like it was supposed to. They immediately shipped me 6 new pieces, that piece that was missing from the machine, because they realized this was some sort of manufacturing problem that others had experienced. Sent me the pieces I needed, sent me the guide, and I was able to get those back up and running, which was nice.
So I wanted to follow up on that statement I made earlier so I make sure I'm being clear about what Evan had said in the chat. The Bamboo Lab systems, it appears that the print info runs through a Chinese-based cloud service. And so for some bigger corporations and stuff, or corporations or bodies that have security concerns, like info security issues, that might be an issue.
Yeah.
So I wanted to make sure I clarified that.
I can hop on mic and talk about that. I mean,
Please.
I'm not like a super security expert or an IT person or anything, but my understanding is that they're sort of a startup, and so they don't have all of their security ducks in a row kind of to begin with. But then also the fact that everything that runs on their cloud service gets bounced over to Chinese data centers and then back to the US. Even like the video from the printer goes all the way back and forth across the ocean. And so that's definitely raised some red flags for organizations. I know that we have clients who would that would be a complete non-starter if we were running any of their information. My understanding is that you can put them in like a LAN only mode where you can run a memory card. You can disable all that and run a memory card over and do it that way. So maybe they're still useful for that. That just wouldn't really work for us.
Yeah, that's kind of similar to the issue that we had when we purchased our Ultimaker 2 Plus Connects. Our network permissions and our IT guys simply wouldn't allow us to change the settings so that we could get those printers on the network. So we've just switched over. We just do it by flash drive exclusively until we can get that setting changed.
From a corporate standpoint, I think most companies have those issues. Crown for sure does not allow anything to be connected to their Wi-Fi or connected to their network that's not vetted thoroughly. To the point where we can't even download updates for the preform software without them giving us, access through the firewall to do so, all because of IP, all because of, just those security issues.
Yeah, and that's what I found so useful in having 2 parallel systems running to make my print queue work. We can't use the Ultimaker Digital Factory because of that security issue. So we have the Ultimaker machines running, and at the same time, we're tracking everything manually / automatically in Airtable. So there is a divorce between those 2 sides of the systems, but because we built it to run in parallel, it's able to kind of close that gap that would otherwise occur by not having that software tracking it online.
It looked like Evan also had a question about if anybody here had looked at or was using Mosaic element printers. So if anybody that's out there has any comments on that system, feel free to unmute and jump in. And that goes for if you have any questions or anything for Gabrielle, feel free to unmute yourself at this point in the presentation. Everyone can unmute themselves and just chat, ask questions and whatnot.
This is Scott. I'm so impressed with the whole system that you've built. It's sort of like a coral reef or something that supports a lot of different life forms doing a lot of different things. And I'm aware of what kinds of waves of demand come, in education, but it happens in industry too. And because of that, I'm curious as to what level of self-awareness is built into the printers. In other words, like an FDM, if there's something in the supports or the way that it routes to the base that isn't right and it turns into air spaghetti, does it know that? Or does the whole thing just keep going until it's discovered by an employee in your case?
So it depends on which machine you have. The Bamboo has some sort of built-in AI detector, uses an algorithm to see if you have spaghetti, if you've got a failed print, it'll pause it. I know that 3D Printer OS, which is a queue management system, you can build in so that if that happens, 3D Printer OS automatically pauses the print. But on all of the machines that we have, it's entirely manual. So there's no automatic failure detection. It's just if someone notices it, they can walk up to the printer and pause it. Our industrial FDM printers, the 370 and the Fortis, they both have cameras. So if I know there's a very, very important overnight print running, I have an app on my phone that I can check. But there is no automation in the systems that we have that would stop that.
I'd like to throw in my lack of support for Dremel 3D printers. They've not been good at all. Use them just like the wow piece. We have them on the top shelf that you can see in the hallway. So people look at it like, ooh, 3D printing, but then you can't really reach them. And it's because we don't ever use them because they just get set. So I'm glad there's other people out there I'm glad we're not crazy and just suck at 3D printing.
I think it's that specific company, that specific machine a lot of people have trouble with. We just recently had a lot of K through 12 teachers in here. We had 20 people in here. We were training them on printing and laser cutting. And a lot of them had been gifted Dremel machines. And especially for someone who has no experience in 3D printing before, it was basically impossible to use. And so they just sit there in their shops as well.
I think Dremel's parent company or Dremel itself went through some sort of certification to get those into schools, and they're one of the few who did, which I believe is why they're so ubiquitous in schools and why they're funded the way they are. As crappy as they are, unfortunately, they're the only ones that meet the bill. When, I mean, you can do, what you guys did with the Ultimakers, I'm sure, and put a filter on them. And I know the Prusa is offering an enclosure with fire suppression and filtering that are phenomenal, but yeah, unfortunate to see that thing in schools that just detracts from the printing in general. I did actually have a question. I know the last time that I toured DAP, DAP in particular had a whole bunch of Prusa Mark IIIs that they seemed like they had kind of gone all in on. And obviously 1819 has the Ultimakers. I think when we spoke, you had said that you might be a little bit aware as to why they opted to go that route as opposed to something else. Is that something you could elaborate on?
Yeah, so there are a couple different shops in DAP and they serve slightly different types of members. So we've got the Rapid Prototyping Center, which is run by staff. But Scott, feel free to jump in since you have worked over in DAP for a while. And then you also have the STL, or the Student Technology Lab. And that one is run by student volunteers, and the machines are sliced and started by the actual people whose prints are running on the machines. So I think a big reason that they went with the Prusas over there was because it's easy for someone to just walk up and operate it with very minimal training. And they also have what's called the Samber Lab, which I believe is industrial design specific, and they use some older Ultimakers and also Prusas in that lab. So part of the reason that we went with Ultimakers was because anybody who's touching those machines, they're going to have some level of training. They're going to be taught by me or by one of my long-term co-ops how to use them and how to integrate this like weird parallel Airtable queue system. You have to know how to do it. Whereas with maybe a Prusa, you can walk up and much more easily just figure it out and hit go.
Perfect. Thank you.
You guys at the 1819, you guys pretty much do all of the employees do all the prints. You don't have students coming in and doing their own prints.
So we are a submission-based model. So you give us your STL, we do everything, you come and pick it up. And then just last month, because we had put all of our first edition Ultimakers in storage, we got our Ulti 2+ connects. That's what we use for our service center now. So we had 9 Ulti 3s sitting there, not really useful anymore to us, not very reliable printers. We are now allowing students to come in and use those retired Ulti 3s themselves. So it's kind of a DIY model, but it's definitely not being used near as much as the service center.
Okay.
I'm curious to either your Gabrielle or anybody else here's experience with the Form XL compared to the 3+. the Formlabs? Is the Excel simply just a bigger version, or is it, does anybody experience different print quality, reliability with the larger version?
Anecdotally, it's the same fundamental physics. It's the same low force stereolithography that they pioneered with the 3, but it uses 2 lasers, uses the same material cartridges. It just takes 2 of them. It uses a much bigger tank itself that it peels the part out of, obviously a bigger platform, but 2 scanning lasers. So I think the idea is that what they would do is they would sort of overlap the scanning lasers to then mitigate the line that you would get from where they would meet in the middle on the part, or it would only use one or the other based on, where it's at on the build plate. I've got a guy that I graduated DAP with who does toys, and they have one. And they said it's pretty good for a lot of stuff. I think because of the size, it has some teething issues, but fundamentally it's the same printer. Where the real difference is, I think, having looked at the whole cohesive ecosystem, is that the printer itself is 11 grand. Your post-processing station through Formlabs is $8,000 for the wash. It's like $4,000 for the cure, if not $8,000. So you're looking at huge investment for, that whole ecosystem. But you're still at, say, 40 grand for a much larger SLA versus 60, 80, 100 grand for a traditional large format SLA. But I've heard they're the same as the Form 3. Quality is all the same. The slice is all the same. You can just do bigger parts, but the ecosystem is very expensive. And Formlabs, I mean, the Form 3s, it's still like $800 for a wash station, $800 for a cure station. So that's not really cheap either.
Yeah,
you,
and I would
Patrick.
point out that, yeah, thank you, Patrick. I haven't used the large ones or the Bs, the ones that are medical based, but while it is awesome to have my Formlabs machines and the Formlabs slicer and the Formlabs print queue management, there's really next to no reason that you would have to buy their branded wash and cure stations. You would have a bucket of isopropyl alcohol and get very similar results from that. So if you wanted to purchase much cheaper versions of both the wash and the cure stations, that's absolutely something that you could do.
It's a good point. It is interesting that a lot of the DLP systems, their ecosystems, it's like all in one. Like I think Anycubic, it has sort of an all-in-one solution. Even the new Prusa SL1 or whatever, it's kind of an all-in-one solution. They're all fractions of the cost of anything that Formlabs puts out. But then like DLP, what I found is the size of the build is typically more of a rectangular build envelope, where SLA is more of a square.
Yeah.
So like we've got a couple origins here at Crown that are large, but they can still do like 13 by, no, like 9 by 6 by 13. It's always kind of that rectangular form factor, which limits a little bit. But anyway, Michael.
So I actually had a question about Airtable. I wanted to visit that again. Here at Garmin, we're kind of stuck with Jira because it's what everybody in the company uses, unfortunately, for tracking and interacting on stuff like that. But it sounds like Airtable might be a really excellent option for that, for a smaller company or a leaner group that just needs to communicate from multiple locations, but without the funding of something like a large corporation. I was just curious, as far as like, we saw some forums and stuff in the background when on one of your slides, but I was curious how much work it was to set it up to really customize it the way you wanted. And what advantages you see to that over just using like an Excel spreadsheet. I know you mentioned customizability, but I was curious at what cost, does that customizability come? Does it take you a long time to get it set up the way you want it optimized?
Yeah, so we just had to rebuild our submission queue database because we wanted a new one for the new financial year, close out all of our old information. And it just took me a couple days to set it up, but I have been using Airtable for a little while. I understand, how the hierarchies of information are structured. But the huge advantage with this is that it has an automations function. So it sends out automated emails. It can automatically update projects if that's something you needed to do. It can send you alerts if there's something abnormal happening in the system. And I would say that for someone who's never used Airtable before to maybe come in and have a form-based submission like we have, it would take, you know, maybe a week to do the work of researching how this interface works, plugging everything in. And if you already have an Excel sheet with all that data, you can import that. So you don't have to start from scratch if you don't want to. You can bring in data from other programs into Airtable. And the fact that it is customizable downstream, if I realize I want to add a piece of information about for the members to submit about their projects, I can do that so quickly and it live updates to my form. So I have very little work I need to do later if I want to change something.
And you mentioned that you used it for actually being able to show people like a queue for all the printers, like a status and all that for how all the printers are running, when they're going to be done and all that. How much input does that take for from your staff versus how much of it's automated?
Yeah, very little. So the way the timeline works is there's a automatically populated field for what time the print is submitted. My workers input what time it actually starts on the machine, and then based on whatever from the slicer, the calculated, you know, machine time is, it assigns a completion time. So you've got those 3 pieces of data originally came in, started on the machine, and then it automatically figures out when it's going to finish on the machine, and that's enough to populate my timeline. And it's super helpful, I would say, especially during the very, very busy parts of the semester when people otherwise would be calling me on the phone and emailing me all day long to figure out when their parts are ready. We can just send them to this timeline.
Right. The only other comment I had was I was curious if you guys had looked at if you'd looked at Onshape at all as a 3D software. I noticed you mentioned Fusion 360 and SolidWorks, but I've been hearing a lot more about Onshape lately, and they seem pretty promising as a software package, very similar to SolidWorks. But I'm just thinking about it from the perspective of a college student. The fully featured version of it, well, mostly fully featured, is free to anyone to use. It's just you have to be okay with the work you're doing being on the cloud and available, like, open source essentially. But it's all hosted on Amazon servers. It's secure and all that. But I mean, basically, for a college student, you can use a fully featured 3D modeling software for free. And as far as interacting with it, I've tinkered with it, and I'm pretty proficient in SolidWorks. And I mean, it's pretty much like SolidWorks. In fact, I know at least some of the design team from SolidWorks works on Onshape. I mean, they left SolidWorks to build Onshape. So it's just a thought. I don't know how, economical Fusion 360 or SolidWorks are for a college student to, to access if you're not at school. But I'm just thinking for somebody who may be leaving college and doesn't have access to a seat of software, in a lab or whatever, it's an option. So I thought I'd bring it to your attention.
Very cool. I'll have to check that out.
I'll
I'll
definitely second what Michael was saying. I've recently not switched, but started using Onshape instead of SolidWorks. And I'm not that advanced at SolidWorks, but it's been a very seamless transition, I guess. It's if you're familiar with one and Fusion 360, you fall right into it.
Scott, you started to say something. Go ahead.
Yeah, if there's time, I hope. Gabrielle, I was wondering if you guys had any air quality testing, done ever. You kind of mentioned about the filtration and some of the problems with the microplastics and stuff in the air. Have you had any kind of monitoring from the safety department from the university or yourselves?
It's a great question. We haven't had any air monitoring technology in here. The most recent safety monitoring that we've been doing has been all decibel level. So that's probably more front of mind just because of the fabrication shop. And we haven't done any actual testing of what the quality in here is. That leads me into, it looks like in the comments, someone was talking about waste materials. Because we do SLA printing and we also do dissolvable supports on our industrial FDM printing, I feel really lucky that UC has a system in place for removing hazardous waste from this shop. So we obviously have to contain it and label it and do our part. But at the end of the day, when I need materials removed, there is a team of people who come and do that for us. If you're thinking about introducing SLA or dissolvable supports to your own shop, it's a huge consideration to take. How is that going to get out of here safely? How am I going to store it in the meantime? Definitely something important to think about. So thank you for bringing that up, Bruce.
I think to that end, PPE with SLA is crucial, as a lot of the resins may not actually have, like, very long-term effects, but they can certainly have short-term effects. Like, you can become allergic to them and then you can't even go near them. So gloves are essential for that. And to, the waste stream part of that too, we have to have that in place here to have them in a corporate environment as well.
So one of the benefits I've found of the sort of Formlabs ecosystem is if you kind of set everything up right, you don't ever actually have to touch the sticky resin. Like, if you just train everyone to grab the build plate by the handle, put it right in the form wash, then it comes out of the form wash clean, and you never have to actually touch the sticky part. You can swap the trays without having to clean them. You just put them away. It's pretty nice.
We actually had a OSHA safety administrator give us a talk a year or two ago, and they actually spoke about the microplastic issue and the air quality considerations. I don't remember exactly what they said as far as what it involved. I believe it was a device they basically just sat up in the workspace that kind of was just a particle sniffer, basically, and they'd leave it up for 6 hours or 8 hours or whatever just to measure. It didn't sound like it was a very involved process, but you could just reach out to local OSHA representative, or, I mean, obviously with you being on a university campus, there may be, your safety team there may have the equipment or may know who to get a hold of in your region to have them come in and do that. If you're interested in having that testing done, it didn't sound like it was a big deal. Bruce?
That same OSHA guy also mentioned that PLA particles will shellac the inside of your lungs if you have lots and lots of exposure, because they're supposed to be biodegradable and everything, but he said if they get in there, they will just interact with cells and sort of plate them over. So he said PLA is not the perfect biodegradable dolphins and sunshine solution. So there you are.
Absolutely. And while we do restrict what materials we run on our desktop FDM machines, I am willing to run ABS and other types of plastics on my industrial machines that are completely enclosed. But for example, last year I went down to Washington University in St. Louis, and my colleague Matt down there runs zero ABS in his shop. He's not willing to, take that risk. There's so little research actually done on the long-term effects of these types of things. It's a very personal decision to decide what materials you'll allow in your shop and to what level those are enclosed or not enclosed.
All right, well, we're running a little over time. I suppose I should probably bring us to a close here shortly. Does anybody have any last minute questions before we wrap up? Okay. Well, I had a few closing notes. I wanted to first off, thank Gabrielle for taking the time to join us and give this presentation. It was an awesome presentation. Looking forward to hosting it on our website so people can come back and, access this knowledge in the future. So if anybody does have follow-up questions for Gabrielle, go ahead and send an email over to info@modelmakers.org, and we'll forward it on to her. So last thing I wanted to say, we do have a session coming up next month, August 10th at 11 a.m. Central. Anissa Bolin from, we have a longtime APMM sponsor named Ship and Insure. She's going to come in and talk to us about best practices for shipping really delicate, sensitive models and components, things like that. Is going to tell us how to get the best rates on shipping through the major carriers and all of that, as well as some other details on new materials in shipping, biodegradable, filler materials and stuff like that, so that you can make your, shipping not only safer, but also a little more, ecologically friendly. So with that, we will go ahead and bring this to a close. Gabrielle, again, thank you so much for taking the time to spend with us this afternoon. And
Yeah,
we will talk to you all later. Thank you very much.
great.
Bye-bye.
Thanks all so much. Have a good one.
Thank you.
Thank you.
Thank you.